because if you get in contact with one person that you don't know, then that person will know somebody. Yeah,
Hello, everyone. Good morning. I hope you all recovered really well. I hope you got all home well last night. I suppose you all had a good evening? Well, yes. Cool. Nice. Nice. So today will be a more research-focused day. We will hear 12 projects. We will first listen to Mika, but then we will listen to 12 projects which have their kick-off just around this time. They just started. They were from the call last year, and then 8 projects from the call in 2021. But all really exciting. Some about wood building, more or less. The others on sustainable forestry. You will hear this. Enjoy, and I give the microphone to Mika for about.
Yeah, good morning, everyone. Again, welcome for this day 2 of our conference, and I hope you enjoyed last night. I won't start making any larger summary of yesterday's talks, and it would be a mission impossible, actually, so I can't even remember all the talks we had there. But nevertheless, it was very interesting. Well, Andreas, I can hear. I remember exactly what you said, but anyway, it's recorded, so everyone can check it there. But nevertheless, so perhaps I simply then take one message from yesterday. I remember that when we gave the final and last word to Chris at the panel, so what Chris was stating, so that about the integration of new areas, so and that be curious towards new areas, and because as I was saying also in my speech, and I guess that the other speakers were also announcing that we need these holistic approaches and also other disciplines joining for the solutions we are seeking. So that would be my kind of summary from yesterday. And without any further words, so I would like then to perhaps invite Karina, how is it, so with our first speaker, so that we can then immediately start discussing then the projects we have up and running now. Thank you so much, everyone, and enjoy the day.
Our first speaker is Stefania Fortino from the Technical Research Center of Finland, and she's talking about the increased service life of innovative timber building systems. Stefania. Oh, I'm sorry. I'm so sorry. You're right. Sorry, Frank, it's Forest Map. Sorry. Yes, Forest Map. Next generation of Forest Maps. It's Johan Fransson.
Okay.
You're right.
Does this work here?
Danke.
This one? Okay. Good morning, everybody. Yeah. It was like a mission impossible for me to have another presentation than this one. So I will try to do my best to present the Forest Map project. We started in 2021, or actually 2022, with this project, and it was like a kickoff in Madrid that we joined from our crew. So this project is titled The Next Generation of Forest Maps, and adapting a Nordic success story across the globe. Actually, this project is about to enhance the Swedish forest attribute map, not only using LiDAR data, but using other data sources, and also in an AI framework. So I just start the presentation and will show you some of the results. Does this work? I don't know. I will first present the members or the partners in the project. And we have 3 partners from Sweden, as you can see here. Myself is from Linnaeus University. I'm a professor of digitalization in forestry since 2.5 years back. And then we have SLU on board, and also a startup tech company known as Katam. Furthermore, we have 2 partners in Turkey, and also, last but not least, University of Finland represented. And I think we are also, some of us is here among the audience. You can see the globe here. So, and with the marks where the partners are located, but also some of the areas that we would like to use our methodology and test it out when we are approaching that phase in the project. And now I would like to show you some happy faces. These are actually the crew that started the project. We have SLU up in this corner, Jörgen Wallerman and Mats Nilsson, and then we have Anton representing Katam, this tech company, and we have our friends in Turkey, Jem and Elif, and also Jari Salo from University of Helsinki, and he is sitting here in the audience waving with his hand. Professor in marketing in the Department of Economics. And we actually became a few more people in this project. So we actually more than double the staff. And here you can see also the Linnaeus crew. To the left here, we have 4 new members in this project. We have Shafiullah and Jorge. They are also among the audience. You can put up your hands to the audience. And also Dag Björnberg and Esra Sengun. Esra Sengun is coming from Istanbul Technical University and now enrolled as a PhD student at Linnaeus University as a result also from this project. We have here also our friends from Helsinki. I hope I got the right photo. Is it true? But I couldn't find the photo of Mr. Povara Gavalu. And also from Istanbul Technical University, Research Assistant Samet Aksoy and Solnur Topkul. She's a master student. And actually 5 more students are engaged in this project from Turkey. So we are quite a number and growing in size day by day, more or less. Okay, this is the project structure. I showed it in Madrid. It's still the same. We have project management and coordination, and then dissemination and communication as the last work package. And in between, you can see the field data collection in VP2. We will do the modeling here in VP3, and then we will have demonstration cases in VP4. And we will, when we are finished and developed our methodologies and algorithm, transfer the knowledge to Latvia as the first country to be mapped as a result of this project. Yeah, a little bit of the background. In Sweden, we have been using LiDAR data for quite some time, or other data sources, to map the forest. And that we will have been doing by combining remote sensing data with national forest inventory data. And it's not a black box, but it's a blue box. So we have used non-parametric or parametric models to estimate forest variables to produce these raster databases. And the example for these models is like regression models or KNN models, so both parametric and non-parametric. But in this project, we go for AI solutions to map the most common forest attributes. And that is diameter, height, basal area, and stem volume biomass. We will try also to go for tree species classification. Here, if you go back in history, the first map of Sweden was produced at SLU, Swedish University of Agricultural Sciences, back in 2000. And it was based on satellite data combined with natural forest inventory plots. And it followed also from year 2000 here to 2005, 10, and 15. And those are the variables that were mapped, including actually tree species here. So that project has been open and available for the society, and are of course still. But since we started to laser scan Sweden back in 2009 for the first time, we have used laser data or laser-based derived maps. As you can see here to the left-hand side is the version 1, you can say. That was produced using laser scanning data from 2009 to 2015 or 16. And now from 2018, Sweden have been scanned for a second round. and you can see the map here. It's almost completed. We're hoping to complete this and wrap it up this year, but it was not possible because of the weather conditions. But soon we have the second round scanned, started 2018, and hopefully it will end 2025. So it's kind of 7 years between these cycles in the national laser scanning. And as you can see here, it's the same variables, but not the tree species included here. But that is something ongoing, and it will be developed, so we will of course have tree species also in the future. So that is a little bit the story behind. And this slide just symbolizes that we're going from these regression models or non-parametric k-nearest neighbor methodologies to AI framework. So of course you need input data. We use raster images, different kinds, from laser data, from laser-derived metrics, from satellite data, airborne data, and whatever the data you have available. And then you can extract also features from these raster images, and you put in the features and the raster images in this kind of AI framework. And then you can classify things or predict. Our case is more like a prediction of forest variables, but you can, for example, also classify tree species, if you like, and then evaluate the accuracy. And then we started, first of all, in this project with the baseline models. We used regression. So that is the baseline models for the Swedish forest attribute map. And we used 18,000 national forest inventory sample plots. So those are the ones that are laser scanned in the second round. So therefore we used those. And then we came up with these 5 target variables and estimated the RMSE for those. So it's in the range mean tree height. Of course, laser is very good to measure tree height, so it's quite low error. This is a sample plot, 10-meter radius, 10% error, and then we have around 20% for stem volume and biomass, so on. So this is the baseline models that we will compare our results with. We took a next step to develop or use the deep neural network with this ALS data. Actually, from this ALS data, we derived 60 metrics. So it's like height percentiles, vegetation ratios, standard deviation, or whatever you can imagine in this using laser data. So actually behind these results, we have a lot of metrics as input data. And we've been working with this approach. This is just figures coming in, no raster information in this approach. So it's like numbers going in and then a target variable that will be estimated on the right-hand side there. Now we take a next step. This is a type of what we call convolution neural network. And it's a ResNet, residual network for transfer learning. And now we do not only use features, but also raster data as input. You can put in features also, but here the approach is that we use raster data. And we have like this stack of 60 metrics, raster metrics from laser data as a start. This is just to show a sketch of it. You don't need to scrutinize or look too deep into this. But this is the approach going from linear regression analysis to neural networks to like using raster data in a convolution neural network approach. And also, of course, since we have the point cloud from laser scanning, we have also an approach working directly in the point cloud, where we can use point net, for example, and so we will see what we can squeeze out here in terms of improved accuracy and so on. When we built this finally together, I hope we can do some automation or to increase also or decrease the time needed for extracting the target variables. continuing here, this is another slide of some results that we have got so far using machine learning and neural network. Have some other random forest. Random forest is quite popular algorithm used in forestry. So, but you know, you have also kind of decision trees and this kind of things. It has nothing to do with the trees in the forest, but it's kind of nice to have these approaches also investigated. And XG boast another approach, and then produced these raster maps and evaluate these maps and so forth. So it's like an iterative process, and we take it step by step. As I said in the beginning, when we have finalized and are satisfied with algorithm version 1.0, then we will transfer this knowledge to Latvia. Over here is the city of Riga in Latvia. And actually, Latvia is a very good candidate country for transferring this kind of methodology, because they have also national forest inventory, they have laser scanning data, they have airborne data, and of course satellite data. So the approaches that I've shown you will not only include laser data, but we started there, but it will be possible to add on aerial photos, satellite data, or both optical and you could use Sentinel-1, for example, or radar data or other data sources. So this is just to show you that we have a lot of information already prepared in Latvia, and also a lot of possibilities to classify tree species. We have 3,500 samples ready to be classified and evaluated for tree species classification. This is one part of the project. The other part is going for single tree detection, and a lot of algorithms have been used for testing this. This paper is about trying to detect single trees in 5 different regions in Turkey. We have the regions up here, and actually these are the trees. These are the majority is planted trees with some space in between. So it looks quite easy to actually to detect this, but it's still a challenge with the shadows and the trees are next to each other and so on. But these results using what we call YOLO algorithm, you only look once. That is, you collect only data at one point in time. I mean, if you do it twice, you can have like change detection analysis and so on. But this algorithm, you only look once, YOLO, is the approaches that we have been using here. And it worked quite nice. I can't see the results even now here, but we submitted this paper just a week ago, 2 weeks ago. But it works quite fine, I should say. It's like classification accuracy above 90%. Another approach here for single tree detection is, besides YOLO, you only look once, is a SWIN transformer and weighted box fusion-based approach. I mean, this is maybe just some very strange things for most of us to understand what this is really about. But if you can see here, the weighted boxes fusion gave like a single tree detection accuracy of about over 85%, and it was superior to the YOLO version and also the SWIN transformer. So this paper was actually awarded this year at an IEEE conference. So that was one of the best papers presented. So that was really nice. You can see maybe you can see some images down here with boxes and single trees. Okay, something a little bit about the project impact and potential for industrial implementation, or what do we use this for, and is this of any significance? And I would say that monitoring, mapping and monitoring the forest is, for me, very important to follow the forest condition over time, and also in the context of global change. But also for environmental conservation, you can use this for extract a lot of biodiversity indexes and so on. We're not focusing on this in this project, but it's open up for doing these kind of things. And also using new research approaches and so on, will of course open up for even more ideas and so on, how to use the data. Little bit something about the value of scientific collaboration or cooperation. We have 3 different areas here that we try to fit together to get this going. Of course, forest science is a vital part, but we merge this with computer science and social science in this project. Yep, and so this is actually like win-win-win constellation. I mean, without this constellation, we are not moving forward. So this is really important. You can see here at Forest Science, this is Linnaeus University and SLU, and computer science. We have been working a lot with the computer science department at LNU, so we have a lot of collaboration there ongoing. As you could see, we're among the postdocs and PhD students and so on. So that is really happening. And also very valuable collaboration with Istanbul Technical University. And then we have the business modeling in Helsinki, and also Jari have multiplied himself a couple of times and have a crew going on doing these kind of things, because we need to put the value on these maps as well, and that is a little bit novel approach in this project to approach. We will show more results later on about this. Just to wrap it up, we have some publications. We're presenting this at remote sensing conferences, International Geoscience and Remote Sensing Symposium a couple of times, the Vienna conference, European Geoscience Union, General Assembly conference, and so on and so on. So, and we have published a little bit also in journals and conference proceedings. So you can see the publications when you get this PDF later on. I would like to acknowledge, of course, everybody involved, including our founder, and thank you for having me here.
Thank you. Thank you, Johan. There's some time for questions. Who are there questions? None. Don't be shy. Oh, Rune
It
has
was
a question.
crystal clear.
I want to say many thanks, as I'm from Latvia, is that you have a good cooperation with Latvia and with our forest specialists, with whom you are. It's Latvia state woods agency, or with whom you are cooperation in Latvia?
We are collaborating with the institute there, Silava. Yeah? And also the Riga City Forest.
City, thank you.
With Juris Sarins. I think he's quite well known in Latvia and a good network in the Baltic countries. Yes.
Mr. Rune, hello. Ready now? My name is Rune Groen from Research Council of Norway. In my former life, I worked with LiDAR data, and our company at that time claimed to be the first one that had sold a commercial available forest survey. I don't know if the Swedes agree, but at least we claimed it. Yeah. And the problem we had was that laser scanning at that time, at least, was quite expensive, and you have to, as you are working with now, it was also expensive to get the ground truth every time. You had to do it every time for every commune or area that you were scanning. And LiDAR availability, it's good in the Scandinavian countries and maybe in the first world countries, but have you looked at other ways of getting this height and scatter plots of vegetation or biomass, for example, by the way of photogrammetry, which is more available throughout the globe? And you could do, the scatter plot would be the principle would be the same. And then also it would be easier to kind of get impact globally.
It's a good comment and a good question. We actually, as you say, we can use different technologies. We can use stereogrammetry, using 2 satellite images together, mapping the same target, same tree. so we can get 3D models from stereogrammetry, from satellite data. We can use airborne data if available, like photogrammetry. But also if we have like radar data, we could measure height of the forest using interferometry. So we have different technologies and methods that we could use globally. It just matters a little bit about what is available, and our algorithm will adapt to what's available. So if you have the full range with LiDAR data, you maybe have drone data. It could also be included in this kind of models. Because the input data is open into these networks, we need maybe to retrain and train the models again and adapt it to that specific country. That we will test in Latvia, for example, but this forest is quite similar in Sweden, Finland, and I think in Norway and Latvia, more or less. But it's a good point, but we will have like a dynamic, and we have a dynamic and hierarchical approach. Hierarchical in that sense that we could go from different scales, I mean from satellite data down to ground, near range, remote sensing data in the forest. So that is in our mind as well. Yeah. Yeah.
Thank you very. Is it working here? Thank you very much, Andreas Nicolaou. So I have two questions to you. We talked already before your presentation. Our friends and colleagues from Romania had organized a fantastic conference a year ago, and we had discussions on the European monitoring system that is still waiting to be published now by the Commission services. I think it will happen in the next 6 months. There's a lot of criticism, polemics in our sector about that, but I think it's needed. I'm still saying it should be there. How do you connect with this, that it's an integral part of the new system that is really needed, that we have real-time information on our forest ecosystems combined with climate, weather forecast, whatever is happening there? And I don't know if you're following up. There's an expert group to the Commission which is led by Marco Ferretti from WSL in Switzerland and others, and it would be really good if you could connect with that and exchange. Thank you. But great work.
Okay, thank you. We have some ongoing European Horizon projects also approaching this mapping across Europe. So I hope we eventually can go there and have a monitoring system up and running. That is really crucial for the future.
Thank you. Thank you, Johan.
Okay, thank you.
Thank you. Thank you. Okay, our next presentation is from Anja Ramik from Technical University of Munich about the role of biotic and abiotic threats to risk-resilient forest management, right?
Yes. Oh, okay. I take this one. Yeah, okay. Hello, everyone. I'm presenting the project FORECO, and the title, you already said it, is the role of forest recovery from biotic and abiotic threats for risk-resilient management. So the aims of this project are very wide and large. So we aim to provide strategies for sustainable forest management in a changing climate. We want to understand the dynamics of disturbances in European forests, and we investigate and predict the recovery patterns after disturbances. And now, in these 10 minutes that I'm talking here, I would like to give you some exemplary results, some outcome from our project, mostly to the topics 1 and 3. So for the first topic, we try to address a bit more the constraints of sustainable forest management. So we have already discussed yesterday that there are a lot of demands, or there's a lot of pressure on forests in Europe currently. So we have the new EU biodiversity strategy for 2030, we have the new EU forest strategy for 2030, and we have other EU and country legislation that want to adapt forests to climate change, improve multifunctionality, then also strictly protect 10% of the EU land area, which also covers a lot of forests, of course. Then EU forests must be a thing in every country. And all this is happening at the same time while wood demand is increasing. So how can we then sustainably manage forests? This was one question in one of our PhD projects from Konstantin Gregor. He just recently published 3 super interesting papers about this approach. So what we did here was to use dynamic vegetation modeling and robust optimization. So what we basically do is where's the pointer? So we run a dynamic vegetation model with different management options. We have very simplified management options in this model, and we use different climate scenarios here. And from the outcome of the model, we produce or we derive ecosystem indicators about harvest, forest structure, carbon storage and mitigation, or evapotranspiration. So we can derive many ecosystem indicators, and we put these ecosystem indicators then in a multi-criteria optimization in a third step, where we find the optimal share of management given all inputs and parameters. And what we then get out from this are optimized management portfolios that can prevail under any pathway, so under all the climate conditions that we put into the model. So what you see here is now a result from the model outcome for an exemplary site in southern Sweden. So you can see here on the left side all the ecosystem indicators and their performance. And in the second figure, you see how they are optimized so that the ecosystem services are all like equally provided. And most importantly, what you see on the right side is then the management portfolio. This is the colored donut that you see on the right side. So you see that to provide several ecosystem services at a similar level or performance, you get a very diverse management portfolio. So what happens now if we add some constraints to that? So if we in the model enforce stable harvest levels and we enforce strict protection on 10% of the land area, and these hard constraints must be met under all scenarios, you can see that the ecosystem service indicators are not as equally distributed anymore, and the management portfolio changes to one single management option. And if we now look at all over Europe, you can see here we run the model for across all Europe, adding these constraints to the model simulations, and you can see here in these bars, also always in the left, in the very left bar, you see the optimized portfolio with no constraints. In the second bar, you see the optimized portfolio with all these constraints. So what you can basically see is that there's much less diversification if we have these constraints on the forests and the forest management. And also you can imagine that these constraints then heavily restrict the balanced provision of ecosystem services. So this study has recently been published in Global Change Biology. Then, of course, we were also thinking a bit more about how we can include the impacts of disturbance in more detail, because this also plays an important role for the forest. And we have in this study included disturbances in a relatively simplified way, but of course we want to add more detail here. And the second question then is, of course, are the simulated recovery patterns realistic? And that was a very important topic in our project. So the second point, I will not go into the details about disturbances. You all know that basically. I just want to say that the disturbance size and frequency are increasing across Europe. There were many studies from one of our partners, Cornelius Senf, about these disturbances. And an additional increase in these disturbances is expected with future climate change. And the implementation in the models is currently ongoing in our project. So I want to directly go to the next point. What about the forest regeneration? So here we wanted to investigate and predict recovery patterns after disturbance. And we have a lot of reports on regeneration failure after large-scale disturbances under dry and warm conditions. So in many places it was shown that the forest was basically not growing back. So what the team in my project did here was to assess post-disturbance tree density, the structure and the composition at 143 sites across European temperate forest. this is the map that you can see here on the right. These are all the sites that were sampled, where people looked at the structure and the tree composition after disturbances. So what came out from this survey was that an average 18 years after these large severe disturbances, there was a high recovery potential. This is what you can see here in the figure when it goes to 100%. So the recovery potential was relatively high for bark beetle and wind disturbances, but not so high for fire disturbances. And what we could also see from these measurements was that the structural recovery was generally higher than the compositional recovery. So that means that in the end we have some forest there, but it consists of different tree species, obviously. What we did then also was to map recovery from space. Here we developed novel ecologically informed tree-based recovery indicators from Lancet and Sentinel-2. And these indicators effectively distinguish tree regeneration from other post-disturbance vegetation. So they only look at trees, not at shrubs and other vegetation. And what we found here was that there's considerably more realistic recovery intervals than the approaches that are based on spectral indices. So what you can see here in these maps is the recovery after a storm event in Slovenia in 2008. And you can see that we can map here the pre-disturbance tree cover, the severity, and the bare ground share 3 years after the disturbance. And most importantly, what we can now do is to predict the long-term forest recovery, and we can use these relatively short time series to make these predictions. So we have some observational data, but we can also use the shorter time series to make predictions. This is what you can see here. So that means that these new indicators are suitable for monitoring and also for forest management. So to summarize, in this project, we provide novel tools to evaluate and monitor sustainable forest management and forest recovery after disturbances. And we are very happy to share our results and distribute them. So if you are interested, please get in touch with me or my team members. And I want to say thank you to all the people that are working in the project. And the project partners are Technical University of Munich, so this is Maya University, University of Ljubljana and Lund University, the European State Forest Association, FSC International, and the EIT Climate Kick. Thank you very much.
Thank you, Anja. Thank you. Questions? Comments? None? Oh, yes, there's one.
Yeah, thanks for a super interesting presentation, Anja. I'm curious, in the first part of the talk, this optimization study you did, how did you quantify ecosystem services and perhaps also biodiversity?
Yeah, thank you. Thank you for the very good question. So, I mean, we have model output for carbon, water fluxes. So this is what the model directly calculates. And then we also derive some additional indicators. For example, for biodiversity, we derive from the data that we get out from the model the amount of coarse woody debris, so like dying trees that are still on the ground. And for biodiversity, we also use the structural composition of the forest. So we say if there are larger trees, trees with a diameter of more than this and this much centimeters, then we have like some habitat trees. So it's a very rough classification, but we can use the model output quite nicely to derive quite a few ecosystem service indicators.
Thanks, Anja, really nice. Just the last recovery data, are you planning to use it in LPJ gas somehow? Because it would be really interesting, right, if you get similar projections?
Yeah, exactly. So we want to use these data, of course, to evaluate our model. So we can run, we have now the disturbances implemented, so we can simulate the disturbances, and then we can see what the model simulates for the successional patterns. And this is really the nice thing of the model that we are using, that it can simulate succession and like different tree species. And we then are planning to use the data that we get to validate the model.
Thank you. This is a follow-up question, actually, to the first one. So if I understand you right, when you talk about in the first section of the talk, you assess a kind of balanced ecosystem service provision, equally much of each ecosystem service. How do you assess what's actually balanced? Like, how do you quantify that? Is that on a spatial level or in terms of outputs volume or monetary values, or how?
Yeah, so we have these ecosystem indicators, and then we try to, I mean, this is a multi-criteria optimization that tries to always balance all the indicators that you put in. So this is how we quantify that, basically. So we have some standardization, and we define what is a high value and what is a low value.
Yeah, so I just have a quick follow-up on that last question. So in that balanced scenario, do you then, what are the relative harvesting levels then? Because in the simplified, you had all conifers, and that was the optimal for that, but what's the relative harvesting levels when all things are balanced?
Yeah, so the harvest levels are always the harvest levels before you change to another management option. So that is what we at the moment consider at the harvest as the harvest level that is given. But of course we can change all the assumptions. Yeah, we can also increase this or we can lower it. We can predefine harvest levels for each grid cell from, I don't know, data, and then we can see what the model says and how it changes under given climate conditions. So there are super many options that you have in this model, and you have to decide for when you want to write a paper what you put in there, because in the beginning we had a huge amount of results, so you have to restrict it a little bit. But there is many options what you can do with this whole modeling framework.
Exciting. Thank you, Anja. Thank you. Now we are looking into the use of forest biomass and into the sustainable and multifunctional use. And Todd Snell from Swedish University of Agricultural Science will talk.
Yes, thank you very much for that introduction. So, as we've heard in many talks the last 2 days, there are indeed many different objectives that we want to reach with forest management and forest use. So we want to increase wood production, we want to preserve biodiversity and mitigate climate change. And my project, or our project, aims to find compromises and perhaps synergies among these different objectives for the forest. And for example, we want to answer questions of this kind. How should the Swedish forest be managed to cost efficiently maximize the occurrence of conservation species by 2050 by slowly decreasing the harvest level? What is the consequence on the future harvest levels, and what is the future climate impact of that? And conversely, how will the conservation indicator species and harvest level develop with a forestry that cost efficiently reach the climate LULUCF regulation target by 2030 and beyond? And I could now have used Anja's slide here, because I'm now going to present essentially what she's doing too, but using slightly different pictures here. We're using a forest simulation tool called Heureka. It can simulate different activities such as planting, thinning, cuttings of different kinds. There are also models for biological processes such as growth, ingrowth, mortality, etc. And this is stimulated in 5-year time steps into the future, and here I exemplify this with a forest stand. And out from these simulations comes variable describing the living stand, deadwood, harvest of different assortment, etc. etc. And what we do next is to use this as the basis for prediction of species, biodiversity of different kinds, as you'll see, and also the balance of greenhouse gases, which is the basis for the climate impact analysis. And I will now present these, first the biodiversity components and then the climate components in this project. And in this particular study, then, we made use of these sort of what we call in Sweden conservation species, so species that are affected by forestry strongly and are modern forest use. It's different red-listed species. Here it is fungi and bryophytes. And what we do, we have developed models for predicting the occurrence of these species in earlier studies. And what we do is to predict the occurrence of each of these species throughout the Swedish landscape, or specifically on the 32,000 NFI plots. And that forms the basis or a measure for biodiversity. We also then study climate impact, as I said, and we also predict that at these NFI plots. It is a study that is in review by Jariniemi et al., led by Sampo Soimakalio, who is a partner in the group. And it aims really to capture the different aspects and effects of forest use on climate. So it accounts for changes in the forest stock carbon, fossil emissions embodied in the processing of wood, the decomposition of carbon and its from use with a delay, and then fossil emissions avoided in the substitution of alternative wood products, products for wood. It also accounts for emissions embodied and avoided, and this is considered in so-called displacement factors. And we're using displacement factors that represent the use of wood on the European market that was reviewed and investigated by Elias Hurmekoski and published last year. Okay, so that's a study that is in review. We are investigating sensitivities to different assumptions regarding forest use in that paper. But for the current presentation and for doing this twist of investigating the LULUCF regulation, we restrict this measure of ours to only include these components which are accounted for in the LULUCF regulation. So that's the climate measure that I will let's talk about. Now I'll just go into the optimization a little bit more also, and many of you know that, well, a single forest stand or a plot can be managed in many different ways. Here are 3 alternatives for one of the stands or plots. But there are very many different plots or stands in the landscape, and that leads to many different options. In fact, we have 31,000 plots, and we have simulated management, approximately 12 different management approaches for each of these plots into the future. And then we apply optimization that also Anja brought up, which is essentially the way to select how should each of these stands be managed to reach the objectives that we formulate, that we want to reach with the forest. And that could, for example, be these particular management for these 3 stands. Okay, and now I'm moving into results of the work we're doing. These are preliminary results. The first focused on what is the impact then or how should we manage the forest to make these conservation increase in the landscape, depending on targets focusing on those, or on also fulfilling the requirement in the EU LULUCF regulation. And here are results of that. You see on the y-axis here is the median habitat value. You see that the black line concerns all land, and then we have protected land and managed land. And as you can see, we can actually make these species increase quite dramatically in the Swedish landscape using different approaches, either focusing on the species themselves, but actually they will also increase if we start managing the forest in according to what is expected from us regarding the EU regulation. The management is different. Here you see the proportion of the Swedish landscape that would be managed with different management approaches. This also indeed has an impact on harvests in Sweden. So you see, if you have the conservation, take the conservation approach, it means we assume the linear, well, specified any linear decrease in harvest rates, while the LULUCF regulation really requires us to very swiftly now decrease harvests. And it has the expected positive effect on the carbon sink, which is, you can see here on these lines. However, seeing these very strongly decreasing harvest levels, they should also be, I think they should be put in a historical context, and this is how harvests have been developing in Sweden during the since 1990, and as you can see, they have increased very dramatically essentially after 2015, so reaching these targets can be achieved by decreasing the levels to what we had around 2015. All right, so this is the optimization work we're doing, where we are combining the biodiversity and the climate change mitigation measure, but we also work together with, we're working on a synthesis report, Climate and Biodiversity Informed Forestry and Conservation in Fennoscandia. And in this, we have a number of stakeholders in the Nordic countries involved that will contribute to this. This is currently an ongoing process, and we have a meeting with the stakeholders in November now again. And the work step we're following are described here. We're compiling and integrating relative information, etc., as you can read there, and go into the PDF later on. So with that, I want to thank you all, and also in particularly, the postdocs that are involved in this work and actually doing the work on the bottom line, Federico Lingua and Cristian Montalvo Manceno in my group. So Federico is focusing more on the climate forestry component, while Cristian on the biodiversity component, and then Jari Niemi has done a fantastic job of building up this life cycle calculator, and that has been led by work by Sampo Soimakallio at Syke, who is the Finnish partner, and then Jenny Nordén and Lina Nybacken are partners in Norway, being responsible for this literature review and all our stakeholder interactions. Okay.
Who wants to ask the first question? Anyone? Oh, yes. Christopher.
Yeah, thanks a lot. A very nice talk. I had a question on the substitution. I understand you're going to 2050 or even beyond. Are you considering that with the different, development pathways, the substitution benefit might fade away for some, products?
Yeah, that's a very good and relevant question. So that's a distribution, the substitution effect may decrease over time. And so we have set up a calculator that allows us to regulate this actually. And if I recall correctly, our standard setting now is 1% per year or something like that. But we can vary this using this calculator. And that's, of course, it could be yeah, part of studies, part of the things are happening on the screen here, so I was wondering. That could be, there you are. Yes, indeed. It's important that it can be regulated, but we assumed 1%, I think.
Any more questions, comments? Food for thought? No. Thank you very much, Tor.
Thanks.
Now, I welcome to the stage Andre Boncina from the University of Ljubljana. He will tell us about spatial forest planning, innovative spatial planning.
Dear ForestValue colleagues, I'm really glad to be here and that I somehow became a member of this family. I would like to present briefly the I4 Plan project we just recently started with 4 institutions included in the project, and I'm happy that representatives of all these institutions are today here. So Hen, Adriano, and Anna, and me. Ooh. Does it work? This one? Okay, what is the background of our project? It's multifunctional forestry. This concept is somehow crucial term of contemporary forestry. And there are still different understandings about these concepts and different approaches how to implement it. Considering very different social, economic, and environmental conditions. So I think this concept of multifunctional forestry is not something to be discovered once. It's more about permanent effort, how to implement this in very changing conditions. And this is really a crucial task for people working in the field of forest planning. And there are many associated terms, important terms, related to this concept, like ecosystem services, benefits, goods, forest owners, society, municipalities, stakeholders, and so on. So, forests can provide very different services. For example, protection against gravitational hazards. Forests are a source of timber. They are important for local, regional, national economy, for employment of people. They are important for forest owners, as this photo showed here from karst area with small forest owners with small properties, with this fuel wood after forest fire. Forests are becoming more and more important for public as a place for recreation, education, contact with nature. And of course, multifunctional forestry should provide all desired ecosystem services and at the same time maintain forest biodiversity, forest ecosystems themselves. So our idea is to improve multi-objective forest management planning, so in the way to consider very different conditions, to consider climate change, to consider various demands, increasing demands of society towards forest, to consider diversity of these natural, social, economic conditions across countries. And we have also very different forestry tradition, which should be somehow also considered in the project. So where are the possibilities for the improvement? First, zoning, to define priority areas. It's about prioritizing ecosystem services for selected, so the areas for selected ecosystem services, but not to exclude other services. And then we would like to improve the system of indicators which are important for zoning. They are also important for assessment, for decision making, for defining optimal forest management. We would like to introduce some qualitative methods in decision making and combine them with quantitative methods. And all strategies should be done in the way to consider also climate change, so that they should be in the frame of a climate smart forestry, and at the same time to provide desired ecosystem services. And forest planning is also always activity where forest owners, public should be somehow included. Therefore, stakeholder participation is planned in our project. So here are the main I4 plan objectives of our project. So the first one is related to the zonation, to the zoning of forest landscape into priority areas. The second one is about indicators and these different methods to be applied, to combine them. And then the third one is about strategies. So climate smart forest management and respect to their capacity to supply ecosystem services. The fourth is about spatial prioritization and then effect on the long-term provision of ecosystem services, and to integrate stakeholder participation in the forest planning. This is the structure of our project. It's divided into five work packages. First is about data management, the second about zoning, the third about ecosystem provision, and all three work packages are a basis then for synthesis and management implications. And of course, all work packages run under coordination, and dissemination of the project is very important. So we defined some research questions to be answered, and I'm sure that some new questions will appear during the project. We defined such questions, for example, the first one is forest zoning through these methods, really an effective method for improving multifunctional forest management. We really want to test this. 4 partners are included in this project. So University of Ljubljana, Natural Resource Institute Finland, Poznan University of Life Sciences, and Estonian University of Life Sciences. And study areas are a very important part of the project. So each partner selects one study area in the size of 6 to 40,000 hectares. These study areas are important to test novelties in real conditions. And they are also important for the cooperation with stakeholders inside of these study areas. I think 2 weeks ago, we had kickoff meeting in Slovenia. The first day was in Ljubljana, and the second day in Kranjska Gora. We found important that all partners or people included in the project get insight into the study areas of all 4 partners. So the atmosphere was nice group of people, a great expectation, so that we are optimistic, continue. And this is photo of people, most of them are, not all, but mostly, the majority of researchers included into the project. The photo is just at the edge of Krainska Gora study area, at the pass at the elevation of 1,600 meters. Maybe a few words about the working package 2, which is scheduled just in this first year, so that we are active now in this regarding these tasks. So what is the story about? These areas can be important for defining adapted objectives and measures, for collaboration with stakeholders, participation of forestry sector and land use planning, and they somehow consider ecological and social functions of in all forests. So we selected 5 ecosystem services to be considered. Yeah, and this is the way how zoning will be done. So based on indicators for supply separately and then demand, and all this analysis will run based on raster data. 10 to 10 meter cells will be applied. Okay, the last slide. Main challenges for me, personal view, to coordinate successfully the project. And then we are aware that we are coming from very different countries with different political, social, economical backgrounds, and this we recognized as an advantage, and also as a challenge. And we really want to contribute some novelties in forest planning, especially to zoning approach, as you can read here. Also effective communication with stakeholders and these new methods which should be applied. Thank you for your attention.
Thank you very much, Andrei. Thank you. Are there questions? No? Nothing? A comment? Okay. Coffee is ready. Not yet.
Not yet. Okay.
Thank you very much. Thank you very much.
Thank you.
Yeah. Present. Okay, our last speaker before the coffee break is Rosario Garcia Gil from Swedish University of Life Science or Agricultural Sciences too. Oh, there you are. Assess for S on breeding forest.
Okay, so I don't move around. I have a tendency to move a lot, but I try to stay still. Okay, so is it coming up, the presentation? Just wait. Yes, so that's me, Rosario Garcia Gil. I think I'm gonna take this, otherwise I'm gonna lose my voice now and then. Yeah, so Rosario Garcia Gil from SLU. I'm actually the voice of Katri Karkainen today. She's the Okay. Yeah, so I was saying that Katri Karkainen was the one that inspired this consortium to work on a project that is called Assess Forest. And in a nutshell, what the novelty of this project is that we want to incorporate genetic parameters, genetic understanding of forest and trade-offs into modeling at the stand level and at the landscape level of different management practices. Okay. many problems here. Oh. Okay, and the project is led by this equation. As many of you, all of you, are after sustainable forestry. In our equation, we incorporate economy, climate, and life on land. And the project, to answer that equation or to solve it, we have 2 blocks. And within each block, there are different work packages. One block is empirical science, and the other is modeling at the stand or at the landscape level, you will see soon. So we try to address or contribute to all these SDGs. So bioeconomy, because there is a need to substitute oil-based products, there is a need of increased growth that we know. So far we don't change that aspect, that maybe we can use less instead of demand all the time more. To climate, because we need to preserve forest also for carbon storage, the need for wood that is long-lasting carbon and for long-lasting carbon products, and the need to increase resilience. And then, of course, life on land, which is, we are talking about biodiversity. And is when it comes to modeling, mostly we have been considering utilizing several species in the forest, not only monoculture, but we also, in the more empirical side of the project, we are also considering other ways of assessing biodiversity, which is still a bit complicated to use in the models, but is, for example, the biodiversity of the fungi in the needles. So it's done with metabarcoding. I'm not going to talk much about that, but I wanted to introduce that. And the project is organized in 6 work packages. The first one, work package 1 and 2, are the empirical studies, which will provide information, knowledge, new parameters about genetics and trade-offs into work package 3, which is the modeling at the stand level, and work package 4, which is the modeling at the landscape level. And then we have work package 5, which is amplifying the impact through communication and dissemination. And then work package 6, led by Katri Karkainen, which is coordinating us to actually move forward and reach our goals. Now we'll go through the different work packages and give you some examples of the work we are doing. It's quite a lot of work, so I'm not going to go in detail through everything, because then we fall asleep. And I know I'm sitting between you and the coffee, which I know is one additional challenge. So in the work package 4.1, we are trying to address the trade-offs and the genetic utilization of improved genetic material. So developing models for increasing production and other properties. So when it comes to trade-offs, what is here relevant to say is that typically, at least in the Nordics, when we talk about improved material, we have thought mostly on production volume. That has been the main focus. But now we are starting to realize that only considering volume might not be the best option, because when improvement is for volume, you're also affecting other properties, for example, wood properties, physical and chemical properties. So this is then the task 1, one of the examples of research we are conducting by Luke, Sonia Kujala, and Katri Karkainen. And they are looking into the trade-offs between a chemical component, the stilben, which has to do with long-lasting wood, and the growth, actually. So it might be that by affecting growth, accelerating growth of the trees through breeding, you might be actually affecting such an important chemical component, and that's what they are studying from a genetic perspective. And now I will say that all the studies, genetic studies I'm going to present now, have something in common, not only the trade-offs. We know the pedigree of those progenies, just if you want to have a little bit of curiosity on how we design them, and we have been taking measurements of all kinds. For example, in Norway spruce, my group has been working on wood properties, growth, and the wood property has to do with physical and chemical components. So for the physical components, we use X-ray, diffraction and absorption, has to do with density, fiber dimensions, coarseness, etc., properties which are actually important if you care for wood quality, but also chemical composition utilizing mathematical models based on NIR, near infrared light. And we have observed that at least in the Nordic populations of Norway spruce, increase in volume decreases dramatically density. And also that will consequence in a decrease in lignin content, for example, for those who care. And there are other correlations that we need to take into account. So it's not anymore about just improving for volume, so we need to consider indexes, where we need to weight and balance what of those properties we care more about. And that's what, for example, forest industry can tell us what should we breed for and how to tune the indexes. In this paper that we have published, we also indicated or identified that it's very important to consider also population structure, the origin of the trees, when you model all that sort of correlations and associations between different properties, when you assess trade-offs. But that's a detail for those who like genetics. We also care about abiotic stress. And we have identified that growth and phenology have also interesting correlations and frost damage. So for the trees that are eagerly trying to grow after winter, they have an advantage because if they start growing earlier, they will outcompete other trees, but they're also risking to be affected by frost damage because of backlashes in temperature. So we also need to balance that, and we need to understand it from a genetic point of view and provide that that information down to the wood package 3 and 4 who will model that also into the management practices. So it's not only about volume, you see, we need to think other aspects, wood quality, frost tolerance, etc. We're also trying to assess the plasticity. It's not only about genetics, but even when you have been selecting or ranking certain trees, let's say within Norway spruce, certain populations or genotype, as we call the geneticists, from best to worst, you might think that that stays like that wherever you deploy them, but that's not the case. So there are reaction norms, and when you plant that material that you have improved through a breeding or 2 cycles of breeding, you deploy them in another growth zone, and actually the best ones turn to be the worst ones. And don't ask me best or worst for what? Oh, it depends. I'm talking about indexes. So we are also studying these aspects, which should also be considered in the management practices. And then we are also developing what we call genomic selection models, where we're trying to incorporate molecular information, DNA, RNA information, to conduct early selection, which will be also part of the management practices. And when I say early selection, what I mean is that we can select the trees at the nursery state phase. So when they are maybe just few weeks old, so far we can extract DNA, we can then select them if we succeed in building these models. And that's one way of accelerating, for example, tree selection. And in work package 2, they are not only considering trade-offs, they add also already the element from an empirical perspective, the element of different management practices. They are working on a Scots pine, Norway spruce, and silver birch. Aris Janssons is the leader of this work package. And for example, they have recently been publishing a paper where they have been developing for pine and silver birch new growth, new equations for estimating the growth dynamic of those 2 species, and comparing different management practices and also improved material versus non-improved material. And I can already tell you, and of course probably you already know, common sense, improved material always do better, at least for volume. And they have been considering also wood density. Work package 3, I will not go very deep into it because first of all, I'm not an expert in modeling, so I'm on thin ice here, and also because they are waiting for us to cascade down our knowledge for their modeling. So, but what they want to do is to assess different management practices where they will consider trade-offs and improve and non-improved material at the stand level. While sorry, but I want to mention that it's Jari Hynynen who is leading the project, the work package, and then Clara Anton from Nibio, who is leading this work package. What they are doing is more or less what work package 3 is doing, but at the landscape level. So they are going to consider bread and non-bread material and different management in the context of different management practices. This is what Clara has sent to me. It's rather complex way of thinking, you modelers, very nice actually. But if we pay attention maybe on the green boxes, where I feel more comfortable, what they are going to test is different options. Either they model by no considering trade-offs, no considering that you can have improved material, so basically business as usual. Then they will consider utilizing improved versus non-improved material for growth. And in the last one, not only growth, but also trade-offs with wood quality. And I think here is where the novelty of this project lies, that we are actually incorporating those new parameters or neglected parameters so far, I think, into modeling with programs such as Eureka and others. And then we are no one if we don't tell the story of what we have found. We don't spread or disseminate the word about what we have identified. And it's Arne Steffenren from Nibio, who is leading the work package of communication. And well, he has done a great job. He has organized 4 different work packages, national and international, has contact with the industry and as much as scientists and forest owners. So he has been very, very efficient. But what I want to highlight maybe is this box, the outcomes out of the dialogue with the different stakeholders. And you can read it, you will see common sense, yes, you will agree, yeah, exactly. We need more wood, soft wood, like conifers still important, but keep an eye on hardwoods and so on. But I will mainly then drive your attention, your attention to the very last point there in the right side. So there's no need to tailor the timber resource to a specific industry, but the industry will adapt. I think to me, that's the more transformative aspect of this project, if it's true, I believe so, because so far we have tried to, at least in the Nordics, adapt our way of monoculture, clear-cut regeneration monoculture type of forestry to provide to the industry maximized volume. But maybe now the industry actually has realized that, oh, we need to react because now they are not going to keep providing us in the very same way, the wood, the pole. So the timber. So I think that's very nice, actually, that the industry will adapt, is adapting to a different way of management. And maybe some of you are skeptical, then let me know. I want to learn more about that. So, and I think that is what I wanted to say. Thank you very much for your attention. Now coffee time.
Thank you. Thank you, Rosario. But maybe there's questions. Maybe someone wants to add something. Yeah? No, yes.
Thanks a lot, very interesting. I was just wondering, in your genetic analysis, can you link them to more like tree traits? I saw you had wood density and also SLA and these things, because in our models there's a trend of using like these trait databases to estimate the parameters. And I was wondering if there's also from the genetic side some information on that.
Yes, I mean we are studying with X-ray diffraction and absorption like at least 20 different parameters of wood quality, physical properties of wood dimensions and wood properties, and so density is just maybe the most fascinating example because of the negative correlation with volume. And when it comes to the chemical composition also, is cellulose, hemicellulose, lignin, extractives, but also new chemical composition, and there is no limit to what we can measure. This is about if you are interested in certain property and you want to know if there's a genetic component and how that genetic component correlates positively or negatively with other properties, it's just about starting and doing it. There is so there's a lot of, and then there is also biotic and abiotic responses that we are also incorporating, and so we can definitely work with more traits if your favorite one is not yet there.
Oh.
Thank you. I'm curious to learn more about your conclusion about the industry that they will adapt. So is there anything in your research that actually suggests they will adapt, or that they are ready to adapt, or is it your conclusion that they must adapt?
Well, this is a conclusion out of the dialogue with the many different stakeholders through several work packages, workshops and meetings. So that's, for me, is almost like a rumor. But I can add to that when I have been talking with in other forums about this, the industry is more willing to actually even mix different species. For example, when it comes to pulp production, they are studying as we speak, that if that product will have similar properties, even better. Then we have the cross-laminated wood that also can use different woods. And now I might be entering here again territory where I'm on thin ice, but I'm very interested about this. So I ask around. So this is what I can contribute to your question. So here are experts from the industry probably that know better. But the reality is that here there's many people studying different management practices. So we are doing. So we at least believe that the industry will have to follow. Otherwise, why are we doing this?
Thank you for a nice presentation, Rosario. I was wondering, is it possible to measure the chemical components through remote sensing data? Do you have any ideas about that? Is it possible to measure the lignin and cellulose and hemicellulose components, do you think? Or
I love that question. I love technology, so I try all the time. Actually, talking with your ex-colleague or colleague from SLU that work with remote sensing, we are now not as part of this.
Presentations, and then we will have lunch. Okay, the presentations, there was some confusion, so some people just had a little bite, but they are going to join us now. So there will be everything left. So now I'm excited to hear Stefania Fortino from the Technical Research Center of Finland, and she will present information about increased service life of innovative timber building systems.
Thank you, Karina. Okay, so I'm going to present this new project, which was funded just in this call. And as you see here, now we talk about innovative timber systems. The duration of the project is 3 years, and we have a lot of partners, actually 16 from different countries, 6, and we have also 1 third country partner from Australia, and 7 European industries. So it is very large, like consortium. You can see here the list of our partners. And we have different countries, so also different backgrounds and so on. And important participation of industries as stakeholders mainly. So these companies will support the project so that they will provide materials, they will participate in meetings, and they will share also different views about their activities in this field. Here we are, actually, we have here the work package leaders, and let me take this. Work package leader in ESPO. We had this consortium meeting at the end of May, and it was very fruitful because we started to plan our activities. This is a very multidisciplinary project because we have design, we have experiments and numerical models, and also dissemination communication based on life cycle analysis approaches. So You see here gaps of knowledge and objectives. They are very much connected because we started to think about what are the gaps in this field. Actually, it looks that there is the need of innovative timber systems, especially with open spaces, because now the majority of buildings with offices are promoted to be composed of open spaces. So we need new solutions for this. And there is the need to develop accurate models for long-term analysis based on different loads, but also on environmental effects. And there is a lot of background about softwood, but not so much about hardwood. And this is also a gap. Then there is the need to have a bridge between advanced scientific research and wood engineering practice, and this is connected to the impact about what we talked yesterday. So impact in short term and long term, we need to have an evidence of application of research results. And of course, currently there is, for example, regulations in EU member states, which is connected to standards which are under revision until 2027. So how to solve all these gaps? So we decided to propose an innovative timber system which is suitable for multi-story buildings with open spaces, and to have also a numerical model which includes advanced rheological model for increased service life, possibility of reuse also in our timber buildings, and all of this should be based on experiments on both softwood and hardwood. And all this data and the results which comes from numerical models and experiments will be handled in VTT modeling factory environment by using also LCA analysis. And this is very important, this collaboration between scientific and industrial partners. Here we have the list of our work package leaders, and fortunately there are here also some of my colleagues. For example, from work package 2 and TNU, we have Haris and Mirko present, and also from work package 3, we have Patrick. Then there is, NTNU, University of Galway, and from Italy we have University of L'Aquila, and from Slovenia, University of Ljubljana. And working package 6 is also led by VTT as coordination. And finally, we have Poland. This institute is Lukasiewicz ITEC Institute, which will take care of dissemination and communication issues. Here there is the scheme of our work package collaboration, which is so important, as we discussed just now. And as you see here, we have a lot of different tasks related to experiments and numerical modeling and design. In work package 2, there is the design of the innovative timber building system, and all of this is connected, of course, to coordination, but also to dissemination and communication. So the idea is that all these experts in different fields will do a lot of work to finalize this objective, to have an innovative building systems which will be sustainable. So in a way, we follow the safe and sustainable by design concept which is promoted by the European Commission. So we start from the idea, we continue with the implementation, and we finish with the life cycle analysis. And all of this is done considering all possible types of tests for softwood and hardwood in small sample, medium structural size samples until the end of the service life, which will be monitored. How this is possible? It is possible also because we have very strong collaboration with the partners, and there is a relevant transnational cooperation, because some of of these partners actually are experts in groups for Eurocode 5, and some of them are also involved in constructions or were involved in previous constructions or in current construction. So there is a lot of background about many things, numerical models, experiments, advanced technologies, and so on in relation to construction and to innovative components, innovative connections in timber buildings. Some of the partners also were involved in previous WoodWisdom-Net and ForestValue projects, so there is a background about many of these issues. And the project will also promote mobility of young researchers, PhD students, through short-term missions of constructions and other funding programs. And of course, the young professors, assistant professors in our project will also have possibility to improve their career. In addition, we have next year this WCT conference in Brisbane, Australia, so we will start to present some of our results there. So here, actually, there is some illustration of our innovative system. We propose moment-resisting frames, which are made of both softwood and hardwood, glulam, with innovative beam-to-column connections, which are these, and dowel cross-laminated floor panels, which are these. And especially, they are developed in NTNU. And in University of Galway. In addition, the beams and columns are made of both softwood, hardwood, or also hybrid glulam beams, and these are developed in the University of L'Aquila. And also from Australia, we will have some hints about different solutions. For example, low-graded glulam beams with columns and encased steel bars. So we will somehow compare different results in long term with all different solutions. But mainly the novelty of this proposal is to combine these different solutions within the moment-resistant frame, because without this kind of connections, for example, this presented in NTNU already some time ago and under development, we cannot reach the sustainability of the wall innovative timber building. So at the moment we started with some tests. Tests on small-scale wood samples and to plan also the long-term tests under indoor conditions. And of course, they concern the different solutions I just mentioned. So this started and belonged to the first part of our project. So we have already some deliverables which is related to the plans to be carried out during the project. Of course, we need to prepare a numerical model, and this is a central part of our project because we have to monitor the long-term behavior of timber members under changing indoor conditions by using also numerical models. Now, of course, there are a lot of numerical models which were developed in the last 20 years in Europe, but concerning the viscoelastic creep, mechanosorption, so the long-term response in these models, in many cases we have only one-dimensional models in the sense that there were some tests, so there are quite famous models, for example, in the longitudinal direction wood. but there is not coupling about effects in different directions, especially considering, for example, multi-phase models of moisture in wood. So at the University of Ljubljana, they want to couple multi-phase models for moisture transport with mechanical models in all orthotropic directions of wood. So to have a new rheological model for wood, which includes viscoelastic creep, mechanosorption, but also plasticity. And of course, this will be ready in the end of the project because it is very much connected to the tests. But in the beginning, to start the design and so on, we will use existing model. We have a lot also at VTT, also at NTNU and Galway and in the other universities which participate in the project. So one important part is in the end the sustainability assessment, because the idea is to study the effects of deformation, stresses, which are coming from experiments and also from numerical models, and then to implement the service life concept in LCA models and provide the data interface which will be implemented into the so-called modeling factory environment available at VTT, so that we will be able at least to present some case study related to this innovative timber system, so the different solutions and how this could be considered sustainable in long term. And we will provide some example and possibility also to include new examples. So this final data interface will be available for users, especially industrial users who could then develop better solutions for their innovative buildings. Okay, so this is our web page, which appeared just a couple of days ago, and it was created by our Polish partner. They are taking care about communication and dissemination, and this is very important for us because, of course, you can find here everything about consortium partners, but we will update this with dissemination results, with news, and so on. Then we, of course, participate also in Open Science workshop, and this already started some days ago. Thank you very much for your attention.
Thank you very much.
Thank you very much.
Now, Katarzyna Ostapska from SINTEF in Norway, presenting the project T-Rex.
T-Rex, like the dinosaur.
Like the dinosaur.
It's in German, okay. Yes, hello. I'm very glad I'm presenting after Stefania, and it's an honor to present after Stefania. So our project is also about construction industry, not forestry. And our project isn't focused on new structures, but on the old structures. And it's a very long title that all my colleagues say is too long for anybody to remember, so let's skip it. We'll get to it later. So this is our consortium. We have Norway that is leading this research institute. We have two partners outside research in Norway, which are a consulting and building owner and a Trondheim community, so a public partner. And then we have researcher partners from Spain, from Poland, from Slovenia, from Latvia, and from Finland. So the essential goals of the T-Rex are, we are working towards the old timber that is already in buildings, that can be reclaimed, that can be reused, or that can stay in these buildings when the function is changed. But for it to be safe, one needs to be sure that both fire, structural, health, safety is ensured, and that it's going to work, because we cannot make things sustainable with compromising the safety and things. So sustainability has 3 pillars, and for that we know already, because I learned on the communication workshop that one should tell a story. Why did we actually came with this idea for that project? We have industrial partners who want to adapt buildings, want to reuse buildings, sometimes have to because it's a historical heritage, but also want to because they are nice, because they are something different, because that reduces demolition and construction waste. And we had partners, we have clients in our research institute applied that come and ask, we'd like you to just say if this wood is good enough. But we can't use the same methods we use for just industrial forest. We cut and then we bring this statistically based method that only operate on this population of timber that was cut from one area, because they just don't work for this old timber that has been there for I'm not sure how long, and comes from maybe another building, since they used to reuse them at that time too. So there we need new methods, and we need methods that are fast, that are easily deployable of those buildings, and that are good enough to produce the level of reliability that can make this reuse happen. So what we propose as the solution to involve these industrial partners in our application of what was supposed to be in the beginning a very research project and became kind of a slightly applied research project, and work out what non-destructive testing can we actually readily deploy to be sure enough about this structural integrity of wood. So that's what we're going to find out, which non-destructive techniques are ready enough and accessible to multiple small players in construction industry and give enough results. And then we need to post-process it. That takes a long time. So we need to give them already, okay, what do you do with these results? And that must be automatized as much as possible. And we are going to use our building to test that, to show that, to gain the trust of industry. And the last thing, what we're going to do, we're going to prove this is the sustainable way to go, because as Stefania said, we need new solutions that are sustainable. But there is a promise there that we are going to reuse this new innovative building in, let's say, 50 years. But this promise will not be realized if we don't have methods to reuse it, to quantify this possibility. If we don't have these methods, and we don't have them now, then the reuse is not possible. And that's reflected in current life cycle analysis methods that end at the grave, and they don't really cycle over many cycles. They are one life cycle analysis. So that's what Finland is going to work on, to improve the methods of counting the real sustainability of cascading timber over many reuse potentials. How much does it save? Yes, and all of this should end in the guidelines for the certification, something that industry can relate to and can work on and feel safe in implementing. So this is our operating, what we call our actors or stakeholders. And then T-Rex is really just in that circle. So we strategically want to go to the decommission or reuse of building, get this old timber and work with it to say with certainty for all that this can be reused. And this is how we are going to organize our work. Very simple, in 6 work package. We test in laboratory, we process the data, we test in the field, and we do environmental analysis. And of course, we manage and disseminate results. So if you want to go into the details, this is what the structure looks like with all the tasks in it. The yellow ones is what we already started to work on. So you can see we are not only going to check the structural performance, the density, we also go for fire testing, because it needs to be all in it. And what main goal is to, this this cannot be just a single pieces of timber. This needs to be a lot of timber pieces tested for industry to gain trust, for standardization organizations to get trust to it. So we aim for 200 specimen tested, complexity testing with all of different stages, non-destructive, destructive, mechanical, fire testing in several countries, 3 or 4, so that we arrive in between 600-800 database of tested specimen of 4 different tests. And this is what we are doing now. We are gathering wood, we are gathering timber, structural timber. And you see some in Spain, you see some lying here in Poland, already very nicely labeled, with some in my lab in Norway, not labeled, but scanned. And all this timber, see, one thing is that they're all different. They don't look like the one you buy in the shop. And the methods for the one that you buy in the shop just don't work on them. So that's why we have to step in here. So this is what we started doing. Some of the non-destructive testing that we do, it's experimental model analysis. We check how this beam vibrates to get idea of its structural performance. We do the same with sound wave, ultrasound sound speed in this element. We do imaging with LIDAR, a portable one in a phone, but also different types. And we do density, for example, with a resistograph. We are going to do all these tests, a little bit different in each country, but with this basic core of the same everywhere, so that we have repeatability of results and we can actually make it into one coherent database. And then we do destroy them. That's a big task if you think 800 tests like that. And then you see here this blue columns. This is the range, how they differ in length. And that means it's not one test for all. You need to adjust. It's a cumbersome, it's a big task. So once again, most of our task is just test, and try to find the best testing that is not gonna overwhelm us. And our pilot, it's this beautiful, the first red one, beautiful building made of timber that is being adapted to a new modern office, and they want to keep as much of this old timber as possible, especially the pretty roof structure. So what we're gonna do is we get timber from there, test it in the lab, but some the timber that stays there we test on site, and we also cut out samples for material characterization in fire that we send to Slovenia, since fire testing is a very difficult part of it. So you can see here, this is already started some of the first tests. You see our colleague, this is non-destructive. He is testing the enforcing some vibration so that we can measure what happens to this beautiful roof structure when it's like in free state, and then when it's preloaded by our mobile load cell installed here. So you see also my colleague connecting a lot of cables and trying to figure out how the whole system works, not one beam. And this is a movie made already by my institution. I will speed it up maybe, or say this is me talking about what we do there for general public. So we do dissemination, and this is we showing to them how do we gonna test exactly non-destructively on the site, how we try to combine all this non-destructive testing. And in a moment, maybe you see the most interesting part of it, which is our team working together to try to induce vibration on that structure where we can, yes, measure something interesting than just when it stands unloaded. When we loaded it, actually, we thought we can load it a lot, but it started to give sounds quite easily after a few kilonewtons. So that's when we stopped. So it's been there for 100 years, but it's fragile, so it needs to be taken care of very well. Okay, I think I can end with this. So there is like our long-term goals, but we'll not go into that. But one thing only is important, that if we manage to increase reuse of timber and extend this beam's life to not be 30 years, but be again 100 or 150 years, then we make this demand from the forestry lower, because there are a lot of circulates already. And then prices could stabilize for wood. We could have like less problems with
up and down price of wood for construction that sometimes makes all of the small construction manufacturers just makes their job difficult in continuing in business. Yes, thank you.
Thank you, Katarzyna. That was exciting. I think it's a fun project. Who has a question?
Oh, yes.
Sorry about that. I was just adjusting to not having a microphone. I also think it's a fun project. So which question do you get asked by your industry partners? Because you said you had partners from industry more often. Is it how much is it going to cost, or is it how reliable is it going to be?
It's, can you do it for yesterday? It's like we want now the results. We want to know now everything. So for them, time is money.
So there is a real demand. That's pretty cool because that's missing in a lot of research projects. Thank you. That's very good.
Yes?
Merci. You showed this wonderful old building, and under the roof there was no insulation. So can you say something on that?
Yes,
is there something planned and which material?
Probably you showed the part that was under they were, since this is adaptive reuse, so they don't exactly gonna leave it like it is. They architects planned some window in the roof opening, so they were removing part of that. So you could see that this part missing, but because of the fire, they were discussing should they replace the whole insulation in it. So they probably will remove it, and the whole structure on the roof will be changed because they want this, since they want to leave the structure exposed, they want to think about the fire safety, all of this. So what is on top of it needs to be properly replaced. But there's gonna be insulation there, yes. If it wasn't, it means they were in the process, it was on construction site, was in the process of exchange. I'm not into installation. I think they didn't decide on that yet. Probably it's Norway, so mineral wool. But I know that they have this plan for, there are these log walls, and they kind of tighten these elements when they join together, like just carpentry joints. They try to tighten it so everything is fire safe. And to tighten it, they use some sort of organic material and filling, so that like in old times, that they stick in between it. That is, apparently they made fire tests, it makes it much better for fire testing. But it is some sort of fibers, organic fibers, and a little bit of clay, and actually flour mixed with water. It's very old school. But installation, sorry, we are structural, we don't not really know.
Main goals in the company is to drive mass adoption. Do it by letting everybody get the switch.
Hello.
Hi. Type of Web3 app. By
storage of CO2. Under current LULUCF regulations, it would be recorded as sawn timber. I wonder, has there been any work done to look at an additional category to the current standing of LULUCF recording, so the harvested wood pool? Maybe it's a difficult question, maybe we can't answer because it's outside of the scope of your area, but I do think it's an important aspect, and that it will be useful to highlight it in the research that something, an additional category within the harvested wood pool
strategy to
I don't
pursue
know
this?
I think that you mean long-term carbon storage. I think the EU has just developed, proposed a voluntary certification scheme when you, if you do at least 35 years and guarantee that, you can get points for that. And but is that really so that it's going to be good enough? I mean, in our proposal we wrote that trees stand for much longer than that. And trees, when they store carbon, actually store in the roots, in everything. So it's not one-to-one thing to store it in a house or building and to store it in a forest. That's why the whole idea to reuse and to save, to be more respectful of the timber material. But LCA is not my field. We have Finland, Mark Hughes, who is going to work on that from Aalto University. And they've done a lot of work towards trying to do LCA into multi-cycling thing and account for biogenic carbon in a safe way. But I'm really not sure I know exactly what I'm talking about because LCA is very, very far from my... Sorry.
One more question.
A question from the funder side. It's a direct question to, or a specific question to your project, but also a more general project question, also towards Tord that had a presentation earlier today. And he was presenting, you are presenting reclaimed timber, and he was presenting, he's not following, but Tord? Tord? I'm talking to you. No, that's a general question. When you are working with kind of hot topics like reclaimed timber, and you are working with climate smart forestry, you are working in the, when we ask for your proposal, you are writing on the existing literature that has already been published. But in these hot topics, there are a lot of things happening, there are a lot of applications coming in, and either you or us have a full overview of it, because it's not written yet. So the direct question to you is, we have a big project funded by the Research Council of Norway, which is on reclaimed wood, like 30 million euros or something like that. And my question is, Sirtre, yes. Do you have any cooperation with them?
Yes, with Christine and Ure, when we write applications together on that particular forest value. We don't have, but we will have to take our, now we have, actually other partners say they struggle to get wood. We don't struggle, we have too much reclaimed timber. It's hot topic in Norway now, so we have a lot of partners that want to give us wood or sell it for little, and we know we will work with Trondheimer and Holzverk, the waste facility. We can buy wood from them too. We work with Trondheim Kommune, their Gjenbruksbutikk, and they also will give us timber beam when they have them. But I think of it as to use Omtre as a source of wood if they have from barns. They also work on standardization. So we already discussed with our colleagues that we should align and see what they work for standard for recertification, visual grading of the timber. My colleagues would say this doesn't work, visual grading for the current methods for visual grading doesn't work, so that we're gonna work hard on it. We're gonna also use YOLO, you look only once, to check how it's gonna help us to visually grade the timbers we scanned. That's what Omtre also does. So we align, and I mean, our project itself is too little. Everybody needs to contribute. We need more than 800 tests.
Certainly. The way I was looking at Tord was that the same way as I was commenting on you, there are other projects funded by us that are almost picking into the same issues and subjects. So my comment, I don't want expect you to answer it, but it is an issue that ongoing efforts are not, they are, the cooperation between all the efforts or projects it can be good within the project, which you have been discussing today, but maybe it would have been fruitful to have more cooperation. I don't know how to do it, but find each other across funding schemes and countries? I think it's an important question, or an issue, more than that. So it was a food for thought, not a question. Yeah.
Yes, yes.
Thank you, Rune, and thank you, Katarzyna. I give you a present first. Thank you. Thank you. And now I welcome Philip Bester van Niekerk from University of Göttingen with the Wood LCC project.
Okay, thank you, Karina, for the introduction. So this is more of a little update presentation because the project is one of the 2021 calls. So I'm just going to show you what we've done so far. So in Project Wood LCC, we aim to deliver enhanced lifecycle costing in wood construction by novel methods of service life planning. So what do I mean with this? This is sort of our objective, which I just mentioned. And in layman's terms, what it is we pretty much have very sophisticated service life models that were established in previous, especially ForestValue and ERA-Net projects. And we want to take that information and that knowledge, and we want to add this cost layer of life cycle costing. So we want to merge these two fields, life cycle costing and service life prediction. And we have a concept how we will achieve this. And that is shown here on the left, your right. So we want to integrate the building design phase into our service life model. So we have to adapt the service life models, apply it over building design, and then return some information about the performance of the wood materials on, in that design. And because we're dealing with life cycle costing, this is a new field for a lot of us. Most of us are service life modelers in the project. We had to define a very clear scope, which is what you can see in the boxes in the green. Okay, so with that concept in mind, we then started establishing a prototype, and this prototype is more of a process prototype. And like I said earlier, we had to adapt our modeling framework, our strategies, to accommodate the building design phase. So we had to integrate with design software. And before we can do that, we needed to have a design. So this is where our industry partners came in. Swedish Wood gave us this little test house. Here you can see the dimensions of the test house and its specific orientation. We then started playing around with this test house. So we can apply very particular climate scenarios over this test house. The first you'll see is a driving rain simulation. So you can see which parts of the structure are being hit by rain. And the same for a solar simulation, so you can see what, where the sun is striking the building. And what this creates is something like this. This is now an aesthetic change model that we run on top of that information. You can see the weathering of the building that is expected. This specific process has 4 very important things that needs to be the same, or if you change it, then you have to maybe adapt the way that you model. And that is the location, the design, the orientation, and the type of material that you are using. In this case, we just used untreated Norway spruce, and that is how untreated Norway spruce is weathering. That will change if you have a different material. Another very important aspect is decay. So we could see the change in color, but we can also rank the risk of decay development within the building design. So this is what you see in the red. The more red it is, the higher the risk of decay development in that part of the structure. And ideally, you want to go so far as to explode this design and look at everything at the component level, which is what we ended up doing here in the prototype process. And this process is today so sophisticated that we can even identify connection points in the building which leads to what we call moisture traps, where decay is more prone to develop. So with the prototype process already proven, we've written a few papers on that, we disseminated it. We then moved on to our next phase, which was we wanted to develop a software tool. We call it a plug-in within a building design software. But before we could do that, we wanted to have a tangible structure that we can experiment with. So we developed these playhouse structures, and the reason we wanted to have it is we wanted to use it as a validation for our models, and also we want to run these environmental simulations and have a digital twin, which is the design here on the left. So we have 4 of these structures, 4 replicas. The one you see in the photo is the one in Göttingen in Germany, and me holding the color checker. There's another one in Austria, another one in Slovenia, and another one in Sweden. So here you can see what we did then with the development of the software tool. This is the current, not the current user interface, I would say this is the alpha version. This was one of the print screens we had during a project management meeting. And this user interface or the software is made within Revit. We used Revit because it's an industry standard, and also it's BIM ready, which is quite important for us. The BIM enables us to look at the component level, and there's very important information that we can integrate with our models. So here you can see the illustration of selecting a single element in the building, and then there's some information that is delivered. So we want to tap into a lot of that information, and then also run what the previous process we ended up calling the virtual inspection. You run that virtual inspection, and it returns new information that you can then plug into some of these fields. And then at the end of this, we also funnel the right type of life cycle costing data that is needed, like service estimates, the costs of materials, into the right channels here, and overall we get a life cycle costing of the building or a specific element or design. So what I showed you now is, I would say, more of the tangible, front-facing aspect of the project. But in our holistic plan for Project Wood LCC, that is only a part of it. That's only the little houses that have their lights on. There's a lot of processes that happen in the background that's not so easy to convey, especially in a 10-minute presentation. So I will just touch on them briefly, because they are important to mention. So what we are still doing is we are continually updating our service life modeling framework. There's always advancements happening. One of the things we recently added is an in-ground decay modeling methodology, which we ended up publishing also. There's other developments also where a lot of the service life modeling aspects are being improved. Another big aspect was limit states. Limit states have a very large influence on service life calculations, and with things like aesthetic change and cladding, we don't really know when customers are replacing their cladding or doing maintenance. And so we need to understand these limit states. We eventually conducted a survey in 3 different countries, Norway, Sweden, and Germany, with 1,000 participations each. And it was a paid service by Ipsos. And we returned some information. There's a paper in the making. We submitted the paper. We'll see how it is accepted by the scientific community. Lastly, we're always thinking about the integration of life cycle costing. How do we incorporate new processes of maintenance, repair, and scheduling into our modeling framework? So that is always ongoing. And one of the final things that we also work on is this aspect of how do we introduce novel building techniques and building materials to our framework. So there's a large effort now to almost write a protocol of what processes you need to follow in order to incorporate novel building techniques or building components to our methodology. So with that said, this is a summary of all of our dissemination activities. We have a lot of participation in conferences. We have a lot of partners, which I will elaborate a little bit more on in a while. You see we have a lot of masters and PhD students also working on this topic. And we've held numerous workshops to integrate with our industry members and also to learn from people outside of our field, specialists in, for instance, wood coatings that had a dedicated workshop just with us. So here you can see our partners, how they are spread over Europe. The partners in green are new partners. They were self-funded, added to the consortium, showing the evolution of the consortium. And here you can see all of our industry participation. The project has less than a year left. We hope to develop everything that we hoped for. And I just want to, at this point, end the presentation and say thank you to everyone here. Thank you to ForestValue and to FNR for hosting this, and to our industry members that are actually participating in this project and also having a lot of value that they gain from this and participating a lot. If you have questions, it's lunchtime. I'm sorry if I kept you up. There's my email address, and if you recognize some of the partner institutions, you can also communicate with them. Thank you.
Thanks a lot, Philip. Well, that's a generous offer that people can just write you an email, but still, maybe if there's urgent one. No. Okay, then it's lunchtime. Yes, I'm hungry too. Coming back at 2. Hello, hello. Oh, hi. And we continue right away. Thank you very much, everyone, for this good picture. Please sit down. And then I welcome here the Learn for Climate project. Karin.
I'm going to go around. Maybe in there? Should I wait? Okay. So should I wait until people get seated, maybe? Yes, it's on.
Everyone, please take your seats for the final presentations, please.
Okay, thank you. Everybody seems to be ready. Yeah. So I'm Karin Beland Lindahl. I'm an associate professor in political science at Luleå University of Technology. And I will introduce the project Learn for Climate, which stands for Learning to Realize Multiple Forest Policy Objectives Under Climate-Related Stress and Disturbance. So this project is coordinated by Luleå University of Technology in Sweden and includes a number of additional academic partners and also other partners, in Germany, Poland, and Slovenia. So this is an interdisciplinary but social science-driven project, and it focuses on learning. So learning then in our world means changes in values, beliefs, and behavior. So in the social science literature, learning is seen as an important pathway to change. So our project, in a way, addresses, I mean, lots of speakers before me have pointed out excellent solutions to problems and what can be done. But our question is really, is that going to happen? Or if, or how can it happen? So learning can take place at the forest management level, it can take place at the policy level, or among advocacy coalitions. And I'm going to speak more about advocacy coalitions. That refers to groups of actors that shares values and belief and organize to influence policymakers. I'm sure you're aware of several advocacy coalitions. So according to previous research, learning can be triggered by disruptive events. So climate change, for instance, can be seen as a disruptive event, but also climate-related disturbance and stress, for instance, storms, drought, fires. Learning can also be enhanced by knowledge sharing, for example, between scientists and actors. So the aim of Learn for Climate is to support learning that enables concurrent achievement of multiple forest goals while responding to the constraining and potentially enabling roles of climate change-related stress and disturbance. So do policymakers learn? Under the influence of climate-related stress and disturbance, how do forest owners respond and learn? And how do different responses affect future biodiversity and ecosystem service delivery? How can learning be supported to promote goal achievement? So these are questions which are addressed by 4 interrelated work packages. So work package 2, as you can see there on the top of the page, focuses on the policy level. It explores learning among policymakers and national advocacy coalitions. So work package 3, then to the right, investigates learning among forest owners and managers and their response both to policy but also to climate-related stress and disturbance. And work package 4 in the bottom, they will model forest ecosystem service delivery and assess synergies and trade-offs based on forest owners and managers' responses. And finally, work package 5 assess what happens in the project, assesses the collaborative learning among actors and project partners throughout the project. So the preliminary findings, this is an ongoing project, so what I'm going to present now is very preliminary results. But the and I'll start to focus on the policy level. So the preliminary findings suggest that forest policy in these countries have remained relatively stable. Despite disruptive events like storms, wildfires, droughts, bark beetle attacks, that's actually taken place in all the investigated countries. However, changes and more moderate revisions of the existing policies have been made, but to a varying degree and to a varying extent in the different countries. So while most countries have made changes to their policies to address the fact that climate change is actually happening, climate-related stress and disturbance are addressed to a varying degree. So the most far-reaching measures to adapt or prevent disruptive events, that was noticed in the German and Slovenian policies. That's also 2 countries where the magnitude and economic significance of impacts of the experienced disruptive events were significant. The existing institutional structure, that's the rules and norms that regulate existing forest management, may also play a role for learning. So adaptation and change may come easier in countries where the management approach already is aligned or more aligned with the recommended management adaptations. And we can see that there are, as have been shown here earlier, the large differences, for instance, between the dominating forest management approaches in Slovenia or in Sweden. So advocacy coalitions are also clearly important. They're in a position to support, hinder, or even block measures to adapt to stress and disturbance and to change policy. So next, and then I move to the forest management level, how do forest owners respond to climate-related stress and disturbance, and how do they learn? So our point of departure has been based on previous research, which suggests that forest owners can be categorized into different behavioral types based on their objectives and values. So as illustrated in this slide, which is based on the literature, there are so-called economic optimizers, there are traditionalists, there are passive owners, multifunctionalists, and so-called environmentalists, each behaving, responding, and therefore supposedly learning in different ways. So these predicted forest owner times were surveyed in all partner countries and in regions, but they were identified to a varying extent. So in Germany and Slovenia, for example, 4 types were found: the multifunctionalists, the optimizers, traditionalists, and the environmentalists. In Sweden, 3, and in Poland, only 2, multifunctionalists and optimizers. However, more surprisingly, our survey results suggest that within each country, forest management appears to be rather similar across these owner types. Also, owners' responses to climate-related stress and disturbance within each country also showed to be relatively similar, and learning relatively limited. And this was actually a surprise, and this needs still to be validated, but that's what the results look like right now. So other factors that are important to forest owners' learning, that's policy, and a particularly coherence across sectors, so climate, water, whatever other policies, and coherence across levels, EU, national, local, regional. As well as availability of knowledge and technology, maybe to manage forest in different ways, and of course, economic conditions and incentives. The modeling work is ongoing, so we don't yet have results showing ecosystem service outputs given forest owners' responses or different policy scenarios. But in preparation of the modeling, Work Package 3 and 4 have conducted expert workshops in all countries to explore preferred spatial implementation strategies. So they're referring here to the degree of spatial integration or separation of forest functions that are desired. So these strategies are often referred to in terms of land sharing, land sparing, or triads. So in the workshops, the expert indicated their preferred strategies for their countries, given 3 different policy scenarios, 3 different worlds, which reflect also different implementation of EU policy. So they're here labeled biodiversity first, that's the world where biodiversity is prioritized, multifunctionality, and wood bioeconomy first. So the preferred spatial implementation strategies that you can see on this slide varied across countries and across policy scenarios. So in the next step, which is ongoing, the data on forest owner behavioral responses, the survey, and the spatial implementation strategies will feed into model-based assessments of ecosystem services and biodiversity under different climate-related scenarios. And finally then, the outcomes, which are yet to be assessed, will be analyzed in terms of synergies and trade-offs. So our final question addressed how collaborative learning in this context, knowledge sharing between science and practitioners, advocacy coalitions can be used to support goal achievement. So we're organizing 3 national workshops with researchers and representatives for the advocacy coalitions, including authorities and research organizations, and before and after each workshop in which the participants are presented with research results. The participants' states of knowledge are addressed using a short survey. And so far, the results are being analyzed. We can see that the coalitions appear to be relatively stable, but there are also some signs of some actors actually open up for learning and change. So the tentative conclusions suggest that there is learning on both the policy and the forest management level, but it seems to be slow, limited in the sense that it's more prominent on a declaratory policy level than operationalized and expressed in practice and behavioral change. The observed learning also varies considerably in nature and degree between the different countries. So what then, based on a result, could enhance learning? Well, nobody wants to see more disruptive events, but it may be that the magnitude of storms, fire, calamities actually play a role for learning. Policy, and particularly coherent policy frameworks, and that's not where we're now, preferably supported by the dominating advocacy coalition, will most likely promote learning. And as I said earlier, change is likely to come easier in contexts where the existing institutions are aligned with the recommendation adaptive measures, where enabling technology and knowledge is available and where the cost associated with changing management methods can be reduced. But we're not yet finished. These are very tentative results and more is to come. Thank you.
Thank you, Karin. We have time for one question. It's Todd.
What's interesting, you said that there was hardly any difference in the management between the different types of landowners. I'm getting curious on how do you define these different types and how do you define the different managements? And can it be a too small sample size? How was the study conducted? So it's essentially that's the reason why you didn't find significant structures.
No, all of those questions are good, and we need to go back to the data and to look into that. But okay, so first, the forest management types are categorized using cluster analysis, and it goes back to answers to a survey where the respondents are asked to actually answer a number of questions on their values and beliefs. So actually that was not a problem. The different types could be established also in statistically significant in all the countries. But then, and that's also a correlation analysis, and no correlation could be found, or no statistically significant correlation could be found between the owner types and their current management, nor the adaptations that they were ready to make if in response to climate-related change and disturbance. But of course, that doesn't mean that there are no differences, but they're not at least statistically significant in these samples. The response rate, of course, differed in different countries, but in some countries the response rate were actually pretty good, and nevertheless we see a similar pattern. So let's see what that represents, but it was somewhat of a surprise to us, I think, and it may indicate that other factors are more important. That it may be that forest owners want to change, but they're constrained because of economic factors, because of cultural factors, or other things. In the next step, we're going to do qualitative workshops with forest owners, and then we can actually ask them.
Hello. Now I welcome to the stage Yevgen Pilipchuk from Stockholm University, presenting the Bark Build project.
Thank you. Another project coordinated from Sweden, Bark Build. I hope you're gonna see my, okay, great. So maybe I also, can I ask for a pointer or? Great, thank you. So unfortunately, Mika could not join us for personal reasons, so I am the voice of Bark Build today for you. And so the Bark Build is a project about using tree bark in making different materials for construction sector. So the full name of the project you can see on the screen. And it's a network of 6 European countries. So it's coordinated by Stockholm University, Sweden, and then we also have Latvia, Slovenia, Finland, Norway, and Poland. And you can see different organizations participating in our project. So it's Stockholm University, VTT from Finland, InnoRenew from Slovenia, Latvian Institute of Wood Chemistry, NIBIO, it's Norwegian Institute of Bioeconomy in Norway, and Warsaw University of Life Sciences. What's the core strengths of our team and also of our project is actually the team, because we have a unique combination of skills. And you see, this is actually our meeting in Norway. And you see we have different people. For example, Mika is expert in lignin valorization. We have Mark Borega from VTT, and he's expert in biomass processing. We have people also who, for example, expertise in forest products and bioeconomy. For example, Andreas from Norway. Here, this blonde guy in the center. So we have many different but complementing skills in the team, and that's why actually Bark Build project is nice and unique, and also provide very nice results. So the overarching idea of the project is actually to start from industry and to end in industry. And we use industry as a source for our bark. So we work with different barks, for example, spruce bark and birch bark. But the main idea is actually to use these different barks to do cooking fractionation, to develop different formulation, and they apply them and actually make some prototypes. Then we're also actually doing right now assessment of scalability of these products. And of course, in the end, we would like to transfer it to industry, so maybe we will see all these nice products from bark, maybe in our houses or on the market. So here I give overview of our work packages. So first package is, of course, fractionation of bark for wooden construction. So basically how it works, we just take different barks from different industries, and because usually right now they actually just burn this bark for energy generation. But of course, if we could make something more than just burning it. And then actually we develop 2 different applications. In our package 2, we develop wood treatments for outdoor application, and in our package 3, we make materials for indoor application. And after all of this, we evaluate actually the materials we developed. We assess their scalability, and we also do LCA, NTA, and trying to understand which material is most promising for scaling up. Of course, we also have project management and communication and dissemination work packages. So now I briefly go through our work packages. So in work package 1, actually, we start with spruce bark. It's main job of VTT from Finland. They do this alkaline extraction of bark polyphenols. And then actually these extractives we use for wood impregnation. So for example, here you can see a wood sample impregnated with bark polyphenols. And actually it's very nice because bark polyphenols actually act as natural preservatives against fungi. And you can see, or maybe you cannot see, but believe me, these materials are very nice against, to protect the wood against fungal decay. In another direction, actually, we also use these polyphenols from spruce bark to make different coatings. And actually, these coatings are very nice because they can work as volatile organic components absorption. For example, they absorb formaldehyde. I will show it in the next slides. So then, when these materials extracted, we use them in outdoor applications. So for example, we impregnate the wood with subrenic acid from birch bark, and we also check their fungicidal properties. We check their water accessibility, basically hydrophobicity, how they absorb water. And I think this is it for the work package 2. But in this slide, I think it's a bit better explaining what we are doing. So, for example, if you look on a birch bark, it's actually designed by nature to protect birch in outdoor conditions from sun, from rain, whatever. And the same for spruce bark, basically. So what we are doing, we're just combining two different barks, extractives, and developing this kind of coatings. It should be a video. And this coating showed very nice properties. Okay, it's not starting for some reason. Just believe me, this coating is water resistant. And we're also running now weathering tests, and actually they show promising results against water absorption. So in work package 3, we actually develop materials for indoor application, and again, only from bark. And here you see, I say we have no more formaldehyde. And what I mean, that for example, one of the coatings we develop, this is beech uncoated and coated with this carbon materials developed from birch bark, and also some manganese oxides. Actually, what is happening is this coating, when it's used indoor, it absorbs formaldehyde, which could be released from some wood products, and actually it decomposes this to water and CO2. So you can see, for example, within 8 hours, this coating can decompose approximately 50% of formaldehyde in area. So basically, this is very nice material we would like to have in our homes when we have some materials emitting formaldehyde, and this coating just eliminates them. We also developed some different materials free from formaldehyde by design. So for example, we have this fiberboard. We developed it in Warsaw in Poland. And instead of using formaldehyde binders, we actually developed binder from bark, from spruce and actually birch bark, which doesn't have any formaldehyde. And again, this material can be used indoor, and it's very nice and doesn't have any toxic chemicals in it. Another example, actually, is plywood. And as a binder for this plywood, we used a mixture of polyphenols from spruce bark and birch. And actually, this plywood corresponds to all industrial standard, but doesn't have any phenol or formaldehyde. And again, it's actually very sustainable, doesn't have any toxic chemicals. Unfortunately, I could not bring this sample with me. It was not delivered in time. But they look very nice. And this is the most complicated slide. I'm not expert in LCA, so I was always thinking, what should I say here? But in general, we're trying to analyze this case where we have spruce bark, for example.
Yeah, full screen more.
It's PDF, right?
Yeah, good. Okay, good afternoon, everybody. I'm very glad to be here. And first of all, many thanks to ForestValue 2 and ForestValue 2 organizer. You see my face, that's enough. For this very... I haven't touched anything, no? Trust me. Okay. I will keep talking, no problem. So first of all, many thanks to the organizers, to ForestValue 2, and also to the funding agencies, all the respective funding agencies for all the partners within this project. And of course, I'm not alone behind this. There was no space to name all of you in the slide, so that's why I put only my name. I'm joking. So I name each of you individually. So I'm with Spain, with Alexia and Encarna, raise your hand. Then Romania, Bogdan and Lucian. Kyle from Norway, and then we have Harald from Freiburg, Germany, who is also here on behalf of Mark Winkel. Okay? So these are my partners. If the presentation starts, I will show you also something. Maybe it's a problem with the PDF. I don't know. Whether others have used the PDF format? No. Maybe it's the PDF format that creates a problem. it's only a second to last, huh? So try to resist a little bit longer. Thanks a lot. Okay. So you now see what I meant before, so there was no space in the end. Okay, so SOS4 is an acronym for this title, but let me say it's focused on, we hope to, it's ambitious, we hope to define these sustainable operating spaces for European forests. But we have started from some awareness about both the research and the practical side of forestry. And so basically, more than 20% of territories in Europe are located in marginal, rural, mountain areas and inner peripheries. And there's a trigger kind of thinking about the main major challenges in this area, which extends, which are not only environmental, but extends to also socio-environmental aspects. Like, for example, they suffer from the population trend. There is a lack of investments in this area. And also lack of opportunity for natural resources management. So the consequence was that there is this homogenization, so that we got the first gain in this area. So there was also problem related to the structural diversity and homogenization of these natural resources, let's say. So what we basically miss is this connection between so the partnership of forests and forest governance, forest management and forest governance to leverage also some aspects related to social and economic opportunities in this area. Not only thinking about the forest value chain, but also the contact of people with the dependency of people on forest resources. You have to consider that in these areas, more than 50% is covered by forests. And then, as forestry experts in forestry research, we all know that we got a lot of experience in forest ecosystem services assessment. What we currently miss is the linkage between the sources and beneficiaries. So we miss this contact between, we miss the answer to the question, who is benefiting where and what is benefiting to. So we have this missing interlinkage between, for example, urban areas and the mountain areas in this connection in using and benefiting from forest located there. And also in simulation tool, in forest ecosystem models and decision support system, we often miss the combination between climate and social and economic drivers as part of forest management and further and future development of forest resources. So all in all, we don't see, so we oversee these three-dimensional aspects of sustainability related to forests, ecosystems, forest management, forest governance, and forest value chain. So we started from there, basically, in our proposal. So, and basically, we aim to develop deep seer, so driver pressure, state impact, and response indicator framework to cover all these three-dimensional sustainability of forest resources in our landscape, in our case study areas. We want to assess this ecosystem services flow coming from forests by incorporating the socioeconomic and climate dynamics as converted then into forest management alternatives. So finally, our aim is to define these Europe-wide sustainable operating spaces. This is our network. What I want to highlight here, so you see those are all landscapes, marginal areas, mountain areas in several countries in Europe. What I want to mention here is that the partnership is very multidisciplinary. So we got experts in sustainable forest management and planning, forest economics, forest optimization techniques, and also forest-related sociology. I'm not focusing on all the WPs. You see an overview here, how they relate each other. But the project has started on May this year, 2024, and will end on April 2027. So, and this you have here you have a list of the key components of the entire workflow. So we have this building of this comprehensive deep zero indicators framework, which is linked to all the processes, not only the environmental ones, but also the socio-economic ones related to forest resources, in our case, study areas. And then we will co-design and co-build these scenarios as downscaling of the shared socio-economic pathways and representative concentration pathways from the IPCC at very local scale. So we will have these combined scenarios of socio-economic and climate aspects. And then these scenarios, so the narratives behind them will feed then the simulation part, which is the third point. So we will implement Highland, which is a spatial explicit model working at spatial landscape scale to simulate, to translate these scenarios, what comes out from these scenarios into the development of forest and forest ecosystem services at a local scale. Through analyzing the outcomes of the simulation exercise, we will be able to assess the impact and the response functions, so we will be able to set the boundaries, so the ceiling, starting point and ceiling of these sustainable operating spaces. Now we are in the phase of building all these preparatory material. We will end in the core activities only early next year. So we are now collecting the data and setting the case study areas to work. So what will be the main outcome? So you will have an open access place-based matrix of deep zero indicators available at European scale, because we will then align what will be available from the bottom to a larger scale. Then you will have open access spatial maps of and other information layers of forest and forest ecosystem services development up to 2050, so mid-century, which is close enough in any case. So you will have these thresholds and ranges of sustainable operating spaces for some impact and response indicators for the three-dimensional sustainability. And these operating spaces will be then used as a basis to provide policy recommendations and policy options, let's say, at a wider scale. So let's think about a little bit of the impact. So, of course, by defining these sustainable operating spaces, we will be able to support the current climate and biodiversity and nature-related policies at EU scale. So LULUCF regulation, for example, nature restoration law, but by these stakeholders engagement activities, we'll be able to foster also an active dialogue and so strengthen this science practice interface, which is often missing, let's say, in research projects. And by having these boundaries for sustainability and also the targets, we will also able to combine those and align those with other policies that are important in these areas, like, for example, for agriculture on the rural development one, and for let's say the sustainability as a whole, the regional policy, so the cohesion policy. And thank you, and stay tuned. The website will be available, and so you will check all the updates over there. Thanks a lot.
Well done, Matteo.
Done, okay, thanks.
Thank you, despite the technical difficulties. We have time for one question. Who wants to? The one, they're all shy. They all will write to you emails.
Okay, thanks.
Okay. Now, our last presentation is from Pekka Kilpeläinen from University of Oulu. Wood for Health project. Last but not least.
So, hello to each of you, and directly to the next slide. As you all know, wood has significant benefits as a building material. The most relevant, or in particularly relevant for this project, is that it aids the indoor environment quality and can be utilized to reduce energy use for heating and ventilation. On the other hand, wood has the reputation of being prone to contamination and difficult to clean, which has limited its use in application with high demands towards surface hygiene. Our project Food for Health promotes safe and increased use of wood products through the development of antimicrobial surfaces, hygiene concepts, and by providing the first guideline for use of wood in healthcare buildings. One of the strong positive side of the project is its multidisciplinarity. We bring together expertise in architecture, food chemistry and technology, polymer chemistry, microbiology, and coating development. Our project network is presented here. We are the leading partner coming from northern Finland. Then there are 2 partners from Germany and Latvia, and 1 partner from Norway and Sweden. We ourselves are microbiology expert. You all know what White Architecture does. Fraunhofer is expert in coating development and polymer chemistry. Norwegian partner Ulrich is there somewhere, is expert in wood science and engineering. They do analyze mechanical and chemical resistance of those coated surfaces. Latvian partner Bruno is there somewhere, is expert in wood chemistry and also coating development. German and Latvian companies are coating developers and manufacturers. Auro is well known for its ecological paints, coatings, and yet Savniex, you were sure that I'm not able to pronounce it, is expert in use of plant oils in various applications, including coatings. Then I emphasize still expected main results. So at first, guideline that has been missing. No one has delivered or distributed information about what you have to pay attention to if you use wood in healthcare buildings. Then new coatings that would make food surface more easily cleanable, more hygienic, and also antimicrobial. And then, of course, impactful dissemination activities. The guide at first, the starting point was actually a fictionalized redesign of Queen Sylvia's Children's Hospital, so that it would contain as much as food and surfaces as possible. That told us how wood could be used and what has to be taken into account in different premises or rooms or spaces of hospital. And then we have collected good practices of using wood in these healthcare buildings in all partner countries. Naturally, majority of those good practices come from northern countries, Finland, Sweden, and Norway. And then we have compared national regulations for building healthcare facilities, how they affect on use of the food. Again, it's maybe natural that wood is more paid attention to in regulations in Nordic countries than elsewhere. We have written English guide booklet or guide. There is a draft manuscript, and also the initial layout has been planned. And since it's planned by architects, it's really handsome. At least that side will be impeccable, I can guarantee it. And we still have to write a summary how our project has contributed to the knowledge, and then define how we describe, like generally, that kind of concepts like hygiene parameters. And there will be later, at least in Norway and Finland, a national guide where we go a little bit deeper to national regulations and advise wood users based on those. Then about coating developments. And there we have started from point that we don't really know what is the best solution, what works best, and decided at the beginning to test not all possible, but the major solutions. Our coating developers have employed oil-based coatings, acrylate and polyurethane dispersions with antimicrobial compounds. Then their second approach has been to develop new binder systems, completely new. And when it comes to antimicrobials, also natural polymers with antimicrobial effects were tested or have been tested or are tested. We test surfaces for coated and uncoated for their antimicrobial activities. A little bit rarer thing is that we test also antiviral properties. We use their two test organisms, adeno and lentiviruses. They differ from whether they have a lipid envelope around them or not, and we have noticed that they actually differ pretty much on their response to antimicrobial coatings. These same surfaces are then tested also for mechanical and chemical resistance, photostability, flammability, and water vapor damp diffusibility. Little bit more deeply who has done and what. And our work will still continue pretty long time. Germany will complete Food for Health project only in next July, and our reporting deadline is in next October, so there is still 1 year time to continue work. Our other partners stop working with the project a bit earlier. Latvia is specialized in linseed oil-based formulations, has studied, developed them, adjusted them to dry quickly so that they are easily applicable. Manufacturing or preparation process has been developed. Antimicrobial additives have tested, and some other additives are tested still currently. Then German, they have used acrylate-based binder systems with several antimicrobial plant oils, and there are efforts made to integrate antimicrobial biopolymers in polyurethane-based wood coatings, and then completely new binder systems where inherent antimicrobial and antiviral effects have brought about by incorporating fitting compounds directly into the chemical structure. We have tested at least 19 different antimicrobial compounds and used in our experiment at least 15 different formulations, coating formulations. And as I said, the starting point for the research was that we didn't know what would work. And we have, of course, closed off some solution alternatives, have been able to justify some decisions. And we had a project meeting at the beginning of this week in Braunschweig on Monday and Thursday. And we decided to aim to a publication where we explain this process, start from the beginning and progressing to final solutions. And let's see how it goes. It would be also an educative publication to scientific community. Then, of course, Germans may later publish more about more novel and new systems. We have done also other research tasks, and we went to our local hospitals in northern Finland, new hospital in Kajaani containing pretty much wood, and collected microbial samples from different rooms of different hygiene level in hospital. And we did it so that in all space and place we took samples both from wooden surface and another surface, pretty close to each other, as close as possible, and purified DNA from those samples and sent them for sequencing. We got the results actually not last week, but week before. And we know already that the experiment was technologically successful. We really managed to get sequences of those samples and like define the microbiomes, which kind of microbes were growing on those surfaces and their relative abundance. But we have not continued analysis so far away yet that we would be able to say whether there are significant differences between surfaces. And I hope we manage to do it during the rest of the year. In Norway, there has been master thesis comparing natural regulations. As well in Norway, simulation of indoor air conditions in a ward room at Children's Hospital using the water vapor permeability values measured for new coatings. Some of us do also, or that is done in Norway, life cycle analysis of some new and established coatings. Then there is one slide, but that I can skip. Maybe the best dissemination activity, or I liked most, was that European platform FoodPop invited us to give a presentation about our project earlier this year. But that's it. Okay, thank you.
Thank you. Sorry, Pekka, I don't like to be stressy.
No.
You don't believe. Is there one question?
I'm not able to reply to you about wood coatings, but Bruna and Ulrich are here, so they can reply, but most other things I'm aware.
Okay. Well, anyhow, if all these questions come to your mind after, you can send him and his colleagues lots of questions by email. Thank you. Thank you.
All right, everyone. So let me start with compliments. So first of all, thanks to Karina, Katja, the team around you, our technical staff for organizing everything here at the venue, and also for the excellent boat trip we had yesterday. And then, of course, thanks to all the speakers, and especially the speakers of day one, when we actually wanted to tell you about the background, so what we have been doing, how things have been developing and evolving over times, and partly also to show so that what will happen next and what you can expect from our side, so that when it comes to funding these excellent research projects which you have been now presenting. And then thank you to all of our evaluators who obviously are not with us here. They want to stay anonymous, obviously. So, but nevertheless, so their help is, their contribution is, of course, very valuable. So these projects alone now show that we have definitely managed to select the right experts to run the evaluations. So without their help, so we wouldn't be here and with you guys. And what else? So finally, thanks to everyone participating in the event. Hopefully you have been satisfied with the outcomes. And please follow all the social media channels whatsoever. And of course, you can always contact us as well by email or whatsoever. And let's hope that now the event has really boosted networking among you as researchers, because this is the main purpose of these events. It's not just, well, we were now combining the anniversary, but then the launch of these 4 new projects, plus then celebrating the midterm and giving a chance to the projects which have been running for a couple of years now already. But I really hope that you manage to create new connections, find new synergies between yourselves, and that will possibly then lead to new openings when we are to new calls. So thank you so much for your participation, and we'll meet again somewhere at some time. Yeah, thank you. Safe travels back home.
Thank you, Mika. Thank you, everyone. Just one last brief word. Please leave your name tags on the counter over there. Or my colleagues will be angry at me. Thank you, and safe trip home.
Yeah.